So one important use of the ideal gas law is to calculate changes in these properties of the gas as certain things change. So if we change the temperature, the pressure, the volume, what changes does that introduce in the other variables? So one way to calculate changes is to consider the ideal gas law, and I'll use subscripts for say conditions 2, the final conditions. I'll use a 2 subscript, and for the initial conditions I'll use a 1 subscript. So R doesn't change, and so you'll notice immediately that R cancels. So I'll have P2V2 equals N to T2. R is a constant, so it doesn't change even if we change the conditions. Okay, so I have this ratio, so I'll just write it like this without the fraction going across the equal sign. Okay, so this is the ratio of the ideal gas law at 2 different conditions. Conditions 2, final conditions, and conditions 1, initial conditions. So let's see how this might be used. Say we have a balloon, and the pressure is 1 atmosphere, and the volume equals 10 liters. What's going to be the volume of the balloon? Volume equals what at 0.3 atmospheres pressure. As it rises up, gets to about 30,000 feet, we'll have about 0.3 atmospheres pressure, if I remember correctly. It's about 0.3 atmospheres at the top of Mount Everest. So what will the volume of our balloon be? So let's calculate, start with our ratio. P2V2 over P1V1 equals N2T2 over N1V1 that we just got from the ideal gas law ratio. So now let's look at what's constant. N2 equals N1. Because no gas leaks out of the balloon, no mole changes. So N2 over N1, since they're the same, is going to cancel. So I just have T2 over T1. This is a V. I'm supposed to be a T1. I accidentally wrote a V1 there. Okay, so now we didn't say anything about a temperature change, and so the T2 is equal to T1 since no temp change was given. That means T2 over T1 is equal to 1. So we have P2V2 over P1V1 equals 1. So now we have P2V2 is equal to P1V1. We just bring the denominator to the other side, and we can solve for the final volume, V2. Okay, so we just plug in our numbers now. So V2 is equal to, the initial pressure was 1 atmosphere. The initial volume was 10 liters. The final pressure is 0.3 atmospheres. And you'll see that the unit atmospheres cancels, and I'll be left with liters only, which is what I want for volume. So my final volume will be 33.3 liters.